Hello, everyone, and welcome to H&M Technology's online training program. Deep learning is an advanced subset of machine learning that focuses on neural networks with multiple layers. It is inspired by how the human brain processes information. Traditional machine learning requires manual feature engineering, but deep learning automatically learns features from raw data. Deep learning is responsible for major breakthroughs in AI, including image recognition, speech recognition, and language translation. For example, facial recognition systems and voice assistants are powered by deep learning models. Deep learning performs exceptionally well when large data sets are available. It is widely used in modern AI applications such as self-driving cars, medical image analysis, and chatbots. An artificial neural network is the foundation of deep learning. It consists of three main layers: input layer, hidden layers, and output layer. The input layer receives data. Hidden layers perform computations. The output layer produces predictions. Each connection between neurons has a weight that determines importance. Activation functions help decide whether a neuron should activate or not. Neural networks learn by adjusting weights using training data. This learning process is called backpropagation. Activation functions are mathematical functions used inside neural networks. They introduce nonlinearity into the model. Without activation functions, neural networks would behave like simple linear models. Sigmoid outputs values between 0 and 1. ReLU, or rectified linear unit, outputs 0 for negative values and linear output for positive values. ReLU is widely used because it improves training speed. TANH outputs values between -1 and 1. Choosing the right activation function affects performance and convergence speed. Training a neural network involves several steps. First, input data passes through the network. This is called forward propagation. The model produces an output. Then we calculate the error using a loss function. Backpropagation is used to adjust weights to reduce error. Gradient descent optimization helps find the minimum loss. This process repeats multiple times until the model achieves optimal performance. Machine learning often requires manual feature engineering. Deep learning automatically extracts features from raw data. Traditional ML works well for structured data. Deep learning excels in image, audio, and text data. However, deep learning requires large data sets and powerful hardware like GPUs. Both approaches have their own use cases. Choosing between them depends on problem complexity and data availability. Deep learning has revolutionized many industries. In healthcare, it analyzes medical images to detect diseases. In autonomous vehicles, it processes camera data to detect obstacles. In speech recognition, it converts voice to text. In natural language processing, it powers chatbots and translation systems. Deep learning continues to drive innovation across industries. Despite its power, deep learning has challenges. It requires large labeled data sets. Training deep networks requires high computational resources. Deep models are often considered black boxes. Interpretability is difficult compared to simple models. Overfitting can also occur if not properly regularized. Understanding these challenges helps build better systems. In this session, we explored deep learning and neural networks. We understood neural network structure, activation functions, training process, and applications. Deep learning is one of the fastest growing fields in technology. Careers include machine learning engineer, AI engineer, data scientist, and research scientist. With strong fundamentals, students can move toward advanced AI development. Thank you for attending this session.